The next theorem, theorem 4.10, compares two functions f and g based upon their derivatives. So of course we have to start with two differentiable functions, and if their derivatives are the same, we essentially have this kind of a situation. If that's the function f, well, the function g might look like this. Hopefully that is about right. If you notice at every point, say this is x naught, we would expect, at least what I intended to draw here, is the tangent line at the first function and the tangent line of the second function would be parallel to each other. That's what it means to have the same derivative. So let's take a look at the theorem. Maybe it's easier to explain that way. If we take two functions f and g, and they're both continuous on the closed bounded interval ab, and they're both differentiable on the open interval ab, and if further we have that f of x, f prime of x, is equal to g prime of x for all x on a to b, the open interval, then for some constant k in the real numbers, k is going to be an offset, f of x is equal to g of x plus k. So that means if k is a positive number, f and g are going to have exactly the same shape, but g of x will just be lifted up. And if it's negative, it would just be dropped down below f of x. So let's take a look at the proof. It's really only 3 or 4 sentences, and I've already started it. Let's let h be the difference of the two functions, f of x minus g of x, on the closed bounded interval. And notice that because these are both differentiable functions on AB, the open interval, that h is also going to be differentiable on the open interval AB. And their derivatives being the same means that the derivative of h of x is going to be f prime of x minus g prime of x. These are the same. So that means h prime of x is 0 on AB. So by the previous theorem, 4.9, part 2, since h prime of x is 0, h is a constant function. That is, h of x is equal to k for some k in the real line. And maybe I should have specified, or at least I'll state, that h of x is equal to k on the interval ab. Okay, well, that means that, maybe I can continue right down here, but h of x is equal to f of x minus g of x. F of x minus g of x is equal to k, because h of x is equal to k. So h of x being equal to f of x minus g of x is equal to k. And therefore, if we add g of x to both sides, we get what we're looking for. F of x is g of x plus k. And that would be on the entire interval. Simple proof.